is a free and open source security platform used for threat prevention, detection, and response. It is widely deployed across enterprises as security information and event management and extended detection and response (XDR) solution. One of its core capabilities is a cluster architecture, and with a master node coordinates one or more worker nodes to distribute workloads across large environments. Consider a scenario where your organization relies on to monitor every server, endpoint, and network device. Every alert, every log, every detection rule flows to a master node. Now imagine an attacker gains access to a single worker node and, from there, executes arbitrary commands on master with root privileges. That is exactly what minus 2026-25769 allows. In March 2026, the Hawkeye security research team discovered a critical remote code execution vulnerability in the cluster communication protocol. The flaw exists in how the master node deserializes messages from worker nodes. Because the deserialization function imports and executes arbitrary Python modules without any allows, a compromised worker can instruct the master to run any system command. The vulnerability was reported through GitHub security advisories and assigned. Severity, critical. Score, 9.1. ID, minus 2026-25769. CVE 502, deserialization of untrusted data. Affected versions, 4.0.0 through 4.14.2. Patch version, 4.14.3. Learning objectives. Understand how cluster communication works between master and worker nodes. Exploit minus 2026-25769 to achieve on the master node from a compromised worker. Understand insecure deserialization in Python JSON.loads with custom object hooks. Learn detection and mitigation strategies for this class of vulnerability. Prerequisites. Protocols and servers. Top 10 2025 application design flaws. Connecting to machine. Start the machine using the start machine button below. Allow 2 to 3 minutes for it to fully load. Once ready, it will open in split view, providing access to both lab environment and required tools.
Wazuh deployments running in a cluster. Mode use master worker architecture. Worker connects to the master over TCP port 1560. All communication between nodes are encrypted using the shared fairnet key defined in a cluster configuration file OSSecconf. This encryption ensures that only nodes with the correct key can exchange messages. However, once a node authenticated, they must implicitly trust all content it receives. And this is where the problem lies. The master node exposes distributed API DAPI. This enables worker to submit processing requests. Those requests are serialized as JSON and deserialized on master side using Python JSON loads with custom object hook. The vulnerable function. Vulnerability is located framework Wazuh core cluster common Python file. Let me see. Let us see. Backup exploit 2. Maybe data. I don't see this one. Okay. Let me proceed. Function line 1830 1866. This function is to register and an object hook parameter JSON loads, which means every JSON object deserialized from cluster message passes through the custom transformation. When a function encounters JSON object containing callable key, it performs the following operation without any validation. Reads module value from user control input. Calls import module to dynamically import specific module with no allow list. Is get Azure to retrieve any function from imported model. Returns function reference, which is later executed by caller. Let's look at the vulnerability code path. Where do I find this one? I don't think in here. Let me see just real quick. Backup nothing. Exploit. POC. Let us see. No POC. I don't want to see a POC. How do I get these lines? Let me see first. Agents of the Wazuh load balancer. So we have Wazuh agents and Wazuh server cluster. Walking. So receiving managing agent registration request, create shared configuration, groups update, custom rules, decoders, and CDB lists, synchronizing all this information. So now integrity, masternode, walker-node, connection, keep alive, database updating, files, checksum. So we have integrity sync walker, keep alive, check walkers. Wazuh DB in a protocol that we don't need for now. Cluster JSON variable. Let me see. Framework Wazuh core. Let me see it real quick. Core cluster common Python file. Core cluster. We have common Py. So we have this one. Let me see first. It's lines 9, 18, 1830. Let me see, 1830, 1830. This is it. Is instant object class name encode JSON. Do we get the same here? 39. 39. 39. 39. This is 39. Still on that. 39. 48. Let me close panel name. Let me see the changes maybe. Let me see. Okay. Not this one. Parent. 8050 model split. Nope. Span the lines. Nope. graph results. I'm not interested. Then in 40. Bump. Files change. 70. So we. Nope. Compare. No. Common. Show me. I'm searching for common pi. There is no one. Okay. So let me see then something else. 12. Nothing. Common. Let me see something else. Okay. After default user. No, this is not it. It's not it. So let me search for this one. The background story is good, but this is it. So I have the affected versions. So 42. Code. Main. Tags. 14. I guess. Framework. Wazuh. Core. Cluster. Common. Type of fixes. Well, I don't know. Type of fixes. We have 1830, 1830 Wazuh object. This is it. Same we have here, I guess. Callable. The callable Wazuh is encoded. Wazuh get author. Get author. So no validation in here. Module. Callable module. And then import. And then arbitrary import. Return server function. Show that's it. Now DPI, I guess the IP. This is it. The IP. What we have in the IP. What we have. So line 705 is the problematic one. 705 this Wazuh object. So now we have data. Sub process get out fkwrx cdm command. So now the attacker compromises Walknot via initial access inside a thread or supply chain attack. The worker already has shared Fernet key. So this is trusted. Attacker sends malicious DAPI. Request local client execute. The message encrypted in class key and sent over TCP on port 5060. The master API request Q1 receives deserialize message as Wazuh object, processes the callable key, imports sub process, and returns a process get out. Distributed API run local. So now the root cause is twofold. The master trust, all authenticated worker messages without validating the content, and the Wazuh object. What name of the Python file? Vulnerable Wazuh object. Name DPI. Nope. Wait. What? Wazuh object. What name of the file contain vulnerable function? Well, I guess common. I don't know why, but callable import Wazuh object. Okay. What function, Python function, is used to dynamically load module from module field without validation? So we don't have here validation. Input module. What encryption scheme is used to protect cluster communication between worker and master? Encryption 2. Encryption what? Encryption scheme is used to protect cluster communication between worker and master. Fernet key. Again, Fernet key. On which port 5060 child 92 master node. We know you're trying platform. Okay. Let me see. Master. This is the master. Docker. In attached machine. Open the terminal. Check for configuration. More. We have the Zoom and we have the node. To prepare the payload, simply craft malicious JSON. Simply craft malicious JSON. Let me craft this one. Payload. So why do I need this one? Can't export. I need to change this. API. Yes, hello. So we have as well that is called inside F file field. It reads module sub process, imports sub process, and then gets a get output CD ID and the proof. So now we have to do this sudo docker cd exploit docker successfully. So that's sudo docker read book Sending. This is it. Check the listener on. Change this one. I'm waiting. Wait that. No, it's waiting. I don't see anything. This is 43. Okay, into and the same goes. Now I can confirm the shell. Nothing get better. So this that's it. I can use name A. That's it. So Wazuh master specify a chain command execution. But on what Python model does the exploit payload specify in the merging field. Shut process, I guess. What the request type value used to exploit payload to the target mode. What the request type reverse SIEM. Local master. What is the content? Who am I? Wazuh. I do have root. Oh, the root. txt. Wazuh was completed. Wazuh RCE completed. So detection. Now we detect this exploit in challenging because it can uses the same encrypted cluster communication channel as the legitimate traffic. The malicious payload is strictly identical to the normal API request. Only the deserialization function contains different. However, the same server indicators. We can monitor the both network and host level, network level. Detection. Since the exploit travels over the tender cluster port, traditional network monitoring will not flag the traffic itself. However, we can look for anomalies, unusual volume of the API request from the single worker node, cluster communication from unexpected source, API address, connection to the master, port 5060 from non-worker addresses. The most reliable detection happens on the master node itself. After successful exploitation, the attacker command executes the child process of the Wazuh cluster daemon. We can look for processes Wazuh cluster that fall outside normal operation pattern. So you can see the following SIEM request. Process parent name, Wazuh cluster, and not process name, Python 3 or Wazuh with any continuum vote. Unexpected files created by the Wazuh user. Files in temp, reverse shell, connection to originating from the master node. New cron jobs, persistent mechanism installed under the Wazuh service account. Unusual Python models imports in the Wazuh process memory or logs. Log-based detection. Monitor the Wazuh master logs for entire indicating unexpected function calls. While the cluster does not log deserialized function name, by default, any errors resulting from failed exploit attempts may appear in var OSSec logs class log. Look for stack traces referencing as Wazuh object or unexpected model inputs. Vibration mitigation. I beg your pardon. The primary fix, straightforward upgrade to 4.14.3 or later versions, introduces a load list from module, a load in as Wazuh object, blocking arbitrary inputs during deserialization. If an immediate upgrade is not possible, consider following intermediate measures. Restrict network access to port 5060, so only known worker IP addresses can connect. Monitor the audit worker node integrity to detect compromise early. Implement additional network segmentation between the worker and master nodes. Rotate cluster keys regularly and immediately after any suspected compromise for long-term hardening. Any principle of least privilege to the Wazuh service account enable audit logging for all cluster communication events, deploy file integrity monitoring on the masternode itself, review and restrict which users and processes can interact with local client, which patched version fixes 4.14.3. I guess that's it. Thanks for being with me. In this room we covered how Wazuh cluster communication works between master and worker nodes using third-net encrypted messages over TCP port 5060. The insecure deserialization law in the Wazuh object functions that allows arbitrary Python module imports and function execution without any allow list validation. Step by step exploitation of CVE 2026-25769 using the prof.json payload to achieve root level RCE on the masternode for compromised worker. Detection strategies include SIEM queries for anomalies, child processes and host level indicators of compromise, mitigating through upgrade to the Wazuh version 4.14.3 and network hardening measures. This vulnerability highlights a fundamental risk in trust architectures. The masternode implicitly trusted all this serialized content from authenticated workers without validating which function could be invoked. The single compromised worker was enough to take over control of entire security monitoring infrastructure. As we discussed in the technical background, in Wazuh object function was designed for convenience, allowing remote function call between cluster node, but the absence of model anomalies turned the convenience in a critical attack service. Let us know about what you think about this room over the Discord. I hate this room. Really, I hate this room, but thanks. Thanks for it. So long.